Alright, this is another video for Triviti about exercise 63 and exercise 64, and these are kind of difficult exercises about the tangent, sine and cosine, so hopefully everybody understands. I do advise you to try this exercise yourself first, because always if you just see what the answer is, then it looks easy, and then later on if you have to do it yourself, then it might be complicated. So first try it yourself. I'll be giving you the answers in this video now. It says that there's a large wooden chest measuring 1.5 meters by 3 meters, and also the depth of this chest is also 1.5 meters. And it's leaning against the wall, as you can see here. And we need to know what is the height of the point where the chest hits the wall. So what is that height over there? Okay. Now we do know this angle, and we also know that this length is 3. So we can just use that to calculate what that line is. So exercise A I'm going to write down above here, so I have a bit of room to do B and C below it. We want to know, if you take a look at this angle, we want to know the opposite side, and we know the hypotenuse. That means that you have to use the sine. So I'm going to write down that the sine of 49 is the opposite side, which we don't know, divided by 3. So if you do 3 times the sine of 49, then we know the height of point D, which is approximately 2.3 meters. So that is this length. This is 2.3. Then we're going to move on to exercise B. It says, what is the height of point C? Right, so what is the height of this point? Well, actually, we already know the height until here, right? So we only need to figure out, like, what is the height until you are at point C. So what is that length? And if you know that length, we can just add 2.3 to it, and then we know the total height. Well, here we already know that this length is 1.5, so we need to know an angle. If we know an angle, we can calculate something. So you know that this is 49 degrees, you know that this is 90, so you should know that this angle there is 41, because 41 and 49 together is 90, plus 90 is 180, and the three angles together are always 180. So if this is 41 and this is 90, that means that this angle, let me make a little line there, that angle is 49 degrees. So we're going to use that and this length. So if this angle is 49 degrees and we want to calculate the adjacent side and we know the hypotenuse, so that means we have to use the cosine. So the cosine of 49 equals the adjacent side that we don't know divided by 1.5. So if we now do 1.5 times the cosine of 49, then we get the length for that line, which is 0.98. And then we're going to add the this length to it. So the height of point C is 2.3 plus 0.98. I think here, when I rounded this off, earlier it was 2.26. I'm going to use that in the answer here, because then it's a bit more exact, because here I rounded off to 1 decimal place, but here I think we're going to use that decimal place. So if you do this, you get 3.24, and we need to round it off. Well, it doesn't say how we have to round off, so we can just say this in our answer. Okay? So this is the answer for exercise B, and now we get to a difficult question. It says the chest continues to lean against the wall because point C is above and to the left of point A. Yeah, if point C is on the left side of point A, of course the chest will lean in that direction using gravity, like will fall in that direction, but the wall is stopping it. But if point C is on the other side of point A, then the chest will fall back. Right? Now, if you keep pushing the chest against the wall, then this point will be higher and higher, right? But there will be one point where the chest will fall back, right? And that's exactly when C is exactly above A, right? Then it's still in equilibrium. That means that it will not fall back. But then if you push it further, then it will fall back. But the question here, what is the maximum distance between A and the wall when the chest falls back? So here I made a sketch about this situation over here, right? Because here this is half of the chest, the other half of the chest is over here. If C is exactly above A, so if this angle is 90 degrees, that means that it will not fall back yet. But then if you move it even a tiny bit further, right, then the chest will fall back. And the question is, what is the maximum distance? So what is this distance from A to over there? Okay. So what we need to do is, we already know what this length is. So if we were to know like this angle or that angle, then we would be able to calculate this missing length here. So what we're going to do is we're going to calculate this angle first, and then because these two together are 90, we're going to do 90 minus that, and then we have that angle, and then we're going to use 3 and that angle to calculate that line. Alright? So first we're going to calculate this angle. Let me just call this A1, and I'm going to call that A2. So angle A2 is the tangent minus 1 of 1.5 divided by 3. Right? If you do this divided by that, you get A2. And that's 26.56 degrees. Alright? So if I want to know what angle A1 is then, I have to do 90 minus that. So minus 26.56. And that is 63.43. Oh, sorry. It's a bit annoying that it was outside the screen. Sometimes I don't notice that because I look over my camera. Sorry about that. But here we have that angle is 26.56, and this one is 63.43. That's this angle over here. And then we're going to use that to calculate this missing line. So we know we want to know the adjacent side, and we know the hypotenuse. So I'm going to write down the cosine of 63.43 equals the one we don't know divided by 3. So we're going to do 3 times the cosine of 63.43. And then we know that length, which is 1.34 meters. So again, yeah, sorry about this. Maybe I should make another video. I don't know. It's already out of the screen. But here, let me just go over it again, so now everybody can follow it clearly. Here we have the angle A2 is the tangent of 1.5 divided by 3. So then you have this angle, which is 26.56. Then 90 minus 26.56 is that angle, which is 63.43. Then we're going to use cosine 63.43 is the adjacent side divided by the hypotenuse. That's why I wrote on this over here. And then if you want to calculate the missing number, you have to do 3 times the cosine of 63.43. And then you have this number, which is 1.34 meters. So hopefully this is clear to everyone. So this was exercise 63. I also wanted to make a video about exercise 64. I think I'll do that in a separate video because this one is already more than 7 minutes. So I'll make another one. Alright, bye bye.